To determine which eluent we will use for column chromatography, we will use thin layer chromatography, or TLC. To begin, prepare your TLC plate using a soft pencil to mark an X about 1 centimeter above the bottom, where the mixture will be spotted. Then draw a straight line across the short end of the plate, through the marked X. This line is the origin of the TLC plate. To spot the solution on the TLC plate, we need to dissolve our unknown mixture. Make sure that the mixture is finely ground into a powder, otherwise it will not dissolve. This can be done using a mortar and pestle. Add only a small bit of the mixture, about a head of a match, to the spot plate. The solvent used does not need to be the same as the eluent, as long as the solvent can dissolve the mixture and is volatile. It can be used for spotting our sample on the TLC plate. Add just enough solvent for the mixture to completely dissolve. To spot the sample, we will use a glass capillary spotting pipette. Be sure to rinse the spotting pipette with the solvent before taking in the mixture. Do so by taking up the solvent and letting it run out on a paper towel 3 times. Once the spotting pipette is clean, draw up some of the solution to be spotted into the spotting pipette and quickly touch the marked area on the TLC plate to deposit a small drop. Be careful not to hold the pipette on the TLC plate for too long, as this will deposit too much liquid and cause overloading of the plate. To check if enough solution has been spotted, visualize the TLC plate by putting it under UV light. If a purple spot is easily noticed, enough solution has been spotted. To determine which eluent to use, trial and error of running multiple TLC plates of different eluents is required. To develop each TLC plate, place 5 milliliters of eluent into a 250 milliliter beaker. Place the TLC plate in the beaker, making sure that the eluent is below the level of origin line. Then place a watch glass over the beaker and do not disturb the beaker as the plate is being developed and the eluent is moving up the TLC plate. Once the eluent is 5 millimeters from the top, remove the plate and draw a line where the eluent has ended. Once the eluent has evaporated, visualize the plate by holding it under the UV light. Since the mixture contains 3 compounds of different polarities, 3 separate spots should be seen at different levels on the TLC plate. Compound C has a polarity in between compound A and B, therefore it will be the spot in the middle of the other 2. The eluent chosen should cause the compound that is to be isolated, in our case compound C, to have an RF value of around 0.5. To calculate the RF value, divide the distance in millimeters from the origin line to the center of compound C spot by the distance from the origin line to the solvent front, the second line drawn on where the eluent ended. If the RF value is too high, the eluent should be changed to a less polar eluent, and if the RF value is too low, it should be changed to a more polar eluent.
Our next step is to pack our column. About 100 milliliters of eluent should be collected for use in the column. A small amount of this eluent should then be added to the adsorbent, creating a slurry mixture in a beaker. The column should have a cotton piece in the bottom to prevent the adsorbent from running out. A small amount of eluent should be added to wet the cotton piece and ensure it stayed in place. This slurry should be poured into the column using a powder funnel because the mixture is so thick. Let the eluent run out into a beaker by opening the stopcock. While the eluent is running out, tap the side of the column with something that will not damage the glass, such as a soft tube. Make sure to always close the stopcock before the column runs dry. Once the adsorbent is settled and has a smooth surface, the mixture should be dissolved with a very small amount of the corresponding polar solvent. The sample should be loaded into the column using a pasture pipette to distribute it around the inner sides of the column and letting it settle on the adsorbent. The stopcock should be opened to allow for adsorption until the adsorbent is covered by a very thin layer of liquid. To ensure complete adsorption, 1 or 2 pipette volumes of eluent can be added and ran through the column. Using a pasture pipette to add the first portion of eluent. Once a small amount is collected in the column, the rest of the eluent can be poured in using a liquid funnel. This is done to stop any disturbance on the surface of the packed column. Now, fractions can be collected in test tubes and analyzed on a TLC plate. Using test tubes and a test tube rack, collect about 10 fractions to be analyzed. Once sufficient fractions have been collected, mark the TLC plate with 3 X's in a row this time. Using a spotting pipette, transfer the mixture from the first fraction to the TLC plate. Make sure to first rinse the spotting pipette before doing so. Once fraction 1 has been spotted, rinse the spotting pipette again and spot sample from fraction 2, then again from fraction 3. The spots from each fraction should be visualized under the UV light 3 at a time until the compounds wanting to be separated are all able to be identified. Once you have determined which fractions contain an unknown, spot each of the 3 fractions on a TLC plate to be developed. To determine the unknowns in each fraction, visualize the plate under UV light and calculate the RFs. The fraction with the RF of about 0.5 is the fraction contained in compound C, which has been successfully separated from compound A and B.